Hi, I'm Mr. eTutor, your mystery tutor here at mysterytutor.com, and welcome to video module 6-8. In this module, we'll discuss strategies that apply specifically to the diagrams that appear on SAT math questions. Diagrams can tell us a lot about an SAT math question, much more than you might think. Whenever you see an SAT math question with a diagram on it, there are two questions you want to ask yourself. The answer to these two questions will tell you a lot about the best way to approach the question. The first question you should ask is whether the diagram is drawn to scale or not. If the diagram is not drawn to scale, a note must appear beneath the diagram that says "Note, figure not drawn to scale." If that note does not appear, then the diagram is drawn exactly, perfectly, flawlessly to scale. So, that's the first question you want to ask. Is the diagram drawn to scale? If it is drawn to scale, in many instances you can answer the question related to the diagram simply by eyeballing the diagram. Or, after you find the solution in a different way, you can check the validity of your solution by eyeballing the diagram to make sure your solution makes sense. For an example of an SAT math question with a diagram that's drawn to scale, turn to page 462 in your copy of the official SAT study guide by the College Board. Remember, we're only using this book to prepare for the SAT because only this book has real SAT math questions in it. Now, on page 462, question number 14 contains a diagram that is drawn perfectly to scale. You'll notice that the diagram asks you to find the perimeter of the figure, although two sides of the figure are unlabeled. If you simply eyeball the diagram, you might wonder whether the unlabeled sides are exactly the same length as the three sides that have labels. If that's what you wondered, give yourself a pat on the back, you're on the right track. Making marks on the side of your answer sheet, you can measure the length of the labeled sides, and compare that measured length to the unlabeled sides. You'll see that the unlabeled sides are exactly as long as the labeled sides are. This makes the question extremely easy to answer, and takes you maybe 3 seconds to do. Of course, the geometric solution is just as valid, but the point I want to make here is that you can solve the question quickly and easily without doing any math whatsoever, simply by relying on the diagram. So that's one example of a question with a diagram drawn to scale, and how we can exploit the diagram to answer the question quickly. Now let's take a look at a question with a diagram that's not drawn to scale. Staying on page 462 in the official SAT study guide by the College Board, take a look at question number 11. Whenever we have a diagram that's not drawn to scale, we need to understand that the reason the diagram is not drawn to scale is that drawing the diagram to scale would have given the answer away immediately. The College Board only draws diagrams not to scale, when leaving the diagrams to scale would make the questions too simple. So, anytime we look at a question like number 11 on page 462, the first thing we want to ask is, what is it about this diagram that's not drawn to scale? In other words, what is it about the scale of this diagram that doesn't reflect the given information? If you look at question number 11 on page 462, you'll notice that angle X in the diagram is drawn at 90 degrees, even though the information underneath the problem tells us that angle X is greater than 90 degrees. If you redraw line M so that X becomes greater than 90 degrees, you'll immediately see that Y becomes smaller than 90 degrees, which is the correct answer to the question. Now I recognize that question number 11 may not be too challenging, but the point is to look at this phenomenon in a simple context so we can understand how to apply it later to more challenging questions. So that's the first question you want to ask about every diagram that you see on the SAT Math section. Is it to scale or not? If it is to scale, prepare to measure it or eyeball it to get an idea of what the correct answer is. If it's not to scale, immediately ask yourself what about it is not to scale. Whatever that is the key to answering the question. The second thing you want to ask yourself about any diagram is what information has been left out of the labels in the diagram but included in the description of the diagram underneath it. Any information that's left out of the diagram but included in the description will be the first step towards solving the problem. Again, for another simple example of this concept, turn to page 408 in your copy of the official SAT study guide by the College Board. On page 408, look at question number 4. Notice that question number 4 asks you to find the area of the given circle. Also notice that the diagram for question number 4 does not include any labeled dimensions. The description for number 4, however, gives you the piece of information that the rectangle ABCD is an 8 by 12 rectangle. Because the dimensions for rectangle ABCD appear in the description of the diagram but not in the diagram itself, we know that those dimensions will be the key to solving the problem. So our first step in figuring out the area of this circle will be to label rectangle ABCD with its dimensions. We want to write in that side AB is 8 units long, and side BC is 12 units long. By the way, how do we know that AB is 8 and BC is 12 and not the other way around? Well, it's simple actually. Notice that this diagram is drawn to scale. The way we know it's drawn to scale is because it doesn't tell us that it's not drawn to scale. If it's drawn to scale, then the short side, AB, must have the shorter dimension, and the long side, BC, has the longer dimension. You see how this scale thing works on every question that we look at with a diagram? In question 4, the diagram omits the dimensions of the figure, but in the information included underneath the diagram, we're told that rectangle ABCD has dimensions 8 by 12. So, just as I said earlier, the information that's omitted from the diagram but included in the description of the diagram is the first step to answering the question. Once we label side AB as 8 units long, we can see that the diameter of the circle is also 8 units long. If the diameter is 8, then the radius must be 4. If the radius is 4, then the area is 16 pi, which is the correct answer to the problem. And that's it, you're done. Now I realize that this question might not be that challenging, but the point of looking at these standards on easy questions is to be able to isolate the standard and study it on its own. So there you have it. That's 2 questions to ask about every SAT math diagram you ever see. Again, first you want to ask, is this diagram to scale? If it is to scale, go ahead and measure it or eyeball it and see what that can tell you. If it's not to scale, you want to ask yourself what about it is not to scale. Whatever that is the key to answering the question. Finally, if information is omitted from the diagram but included in the description of the diagram, whatever that information is will be the first step to solving the problem. I've just given you 2 basic things you can do anytime you see an SAT math diagram. Almost no test takers know about this. This is definitely an important thing to be aware of, though, if you want to get used to answering math questions in less than 30 seconds. Thanks for watching. There's a lot more to come, and remember, if you do it right, it's easier than you think.